From the September 2020 Kzn. In the diagram, the graphs of f at x and g at x are drawn below. F and g intersect at C and D. A is the y-intercept of f. P and Q are any points on f and g respectively. PQ is parallel to the y-axis. 6.1. Write down the coordinates of A. Well, A is the y-intercept of f, so the coordinates are going to be 0 is to 2. Calculate the coordinates of C and D. At C and D, the two graphs are equal, so I'm going to equate f at x with g of x. Plus x plus 2 is equals to half of x squared minus x. And then half plus 1, that is going to be 3 over 2 x squared minus 2x minus 2 is equals to 0. Then I'm just going to multiply by 2. This is 3x squared minus 4x minus 4 is equals to 0. This is 3x and x. And then this is going to be a 2 and a 2. And then this is minus, that's a positive. This times that's 3x squared. This times that, I'm going to get a 6x, negative 6x, and then plus 2, that's going to give me a minus 4. Yeah. Therefore, x is equals to negative 2 over 3, or x is equals to 2. At D, at D, I can see that that value must be 2, so the y value there is a 0. So the coordinate of D is 2 is to 0. And then now I'm just going to substitute minus 2 over 3. This is a half minus 2 over 3 squared minus 2 over 3. Half minus 2 over 3 squared minus 2 over 3. I'm getting an 8 over 9. So the coordinates of C is a minus 2 over 3 is to 8 over 9. 6.3. Determine the values of x for which f at x must be less or equals to g at x. So this notation, less or equals to g of x. In order for f at x to be less than g, f must lie below g. Then I'm going to go to the point of intersection. And then now I am going to look at where f at x lies below. So f at x is below in this direction. It is also below from there going downwards. But they said it must be less or equals to. So x, the x value there is a minus 2 over 3. And the x value there is a 2. So x should be less or equals to minus 2 over 3, or x should be greater or equals to 2. 6.4. Calculate the length of PQ where line P is between C and D. For PQ, we are going to take the y value there and then the y value at that point. And PQ can be anywhere in between here. Okay, So the y value there, that is that y value, because we can see that P lies anywhere on F. So this is going to be y top minus y below. The graph that is on top is f at x. So this is minus x squared plus x plus 2 minus the graph that is below, x squared minus x. This is minus x squared plus x plus 2 minus half x squared plus an x. This is minus 3 over 2 x squared plus 2x plus a 2. Then I'm just going to find the derivative of that. So this is 2x plus 2. And then at the maximum, the derivative should be equals to 0. Minus 3x plus 2. So x should be equals to 2 over 3. So PQ 2 over 3 is equals to minus 3 over 2, 2 over 3 squared plus 2 into 2 over 3 plus 2. Negative 3 over 2, 2 over 3 plus 2 times 2 over 3 plus a 2. So I'm getting 8 over 3, which is equals to 2.67 units. 6.5. Calculate the value of x where the gradient of f is equals to 3. F at x is equals to negative x squared plus x plus 2. In order to find the gradient, I must find the derivative. This is minus 2x plus 1. And then they are telling me that the gradient is equals to 3. 3 is equals to minus 2x plus 1. So x is equals to negative 1. 6.6. Determine the values of k for which f at x is equals to k has two positive unequal roots. F of x is equals to k. This means that f at x minus k should be equals to a 0. Okay, let's take a look. So they're interested where k has two positive unequal roots. Okay. This line right here, it divides the negative side of the, so this is the negative x-axis. So when you go in this direction, the roots must be negative. And then on the other side, from here going to the right, the roots are positive. So we are clearly not interested in this side. We want to look for our solutions from that point. Let me just clean this up. So our solution must lie from that point going to the right, because that's where I'll have positive roots. Okay. The value of y there, it is equals to 2, because the coordinates of a is 0 is 2. Okay. So my solution will lie somewhere from this point going upwards, because the minute that I go below this point, I'm going to touch something on the negative. So if I say that maybe I'm going to look for my solutions looking at any values below y is equals to 2, my graph touches where? The negative, a negative root. But that's not what I'm interested in. I want to check where my graph is positive, and then to the right. The x values where my graph is positive, and then to the right. So it means that I need to find the value of y at the turning point, because my solution is going to lie somewhere there. Okay, so x is equals to negative b over 2a negative, and then this is 1 over 2 minus 1, which is equals to a half. And then f of half should be equals to minus a half squared plus half plus a 2. I'm getting a 9 over 4. Okay, so now I have that line there, which is y is equals to 2. And then I also have the line at the turning point, which is y is equals to 9 over 4. 9 over 4 is the same as 2.25. So this is 2.25. They are saying the roots should be positive and unequal. Okay. At the turning point, I only have one x value. So the roots are equal there. So I shouldn't include the solution at the turning point. So k should lie between 2, that line y is equals to 2, and then the 2.25. Or we can write this as 9 over 4.